Welcome back. The objective of this video is to show how to use the graphing utility to help us evaluate limits. The dividing out and rationalizing techniques may not work real well for finding limits of non-algebraic functions. We may have to use more sophisticated analytic techniques to find limits of these types of functions. So in this example, we're going to approximate the limit as x approaches 0 of 1 plus x, all raised to the 1 over x power. And we'll want to enter this function into our graphing utility. Let's take a look at the graphing utility and some things that may be of value to you. So here on the graphing calculator, a couple things that are going to be helpful. You may want to get your calculator into the correct mode. We've been using some different modes. I've got my calculator back in the function mode. I'm also going to have it in radian mode for our trig functions if we graph any of those. And you'll also want to be familiar with the table key, the trace option to be able to trace your curves, and the table set. We are going to want to reset our table and look at it at a certain location, and also reset the increments in which we want to evaluate our curve. So the table set is just above the window here, so second window will give you the table set function. So I can exit here, and let's go ahead and enter our function into our calculator. So using the y equals, I have already done so. We're going to explore the limit as x approaches 0 of the quantity 1 plus x, all raised to the 1 over x. And that's the only function I have selected here. My plots are off. And let's take a look at this in just the standard window. We'll just do zoom, standard, and it gives us a nice graph of our function. Now we could trace our function using the trace key and explore some things here. So we've got some x and y values at the bottom of the screen. And you may notice when we get a value of x is 0, we get a blank value for y. So we don't have a y value, or a function is undefined. It appears at x equals 0. And apparently it's undefined in a variety of places there. So let's take a look at the table of values for our graph. So I'll hit second table, and I've got a table of values with some x's and y values. Well, these aren't real helpful. We want to see what happens when we get close to 0. So I cursor to 0, and we don't have a whole lot of information. So we want something that's going to be a little bit more accurate, a little bit more detailed. So let's go to our table set, so second table set, and let's start our table at 0, because we want to see what happens when things get close to 0. And our delta table here, change in table, is going to give us the increments that we want in our table. Now, our table was counting by ones, as you can see here, but let's make our table a lot more precise. We'll do to the, we'll go to 0.001, so to every 1,000th. And let's take a look and see what we get here. Go back to our table. And now we've got a lot more information, a lot more detailed. As you can see here, it appears that our table, as we get closer and closer to 0 from the left or the right, is closing in on something between 2.7196 and 2.7169. We've got some pretty good values here. Now, since we have a really good estimation, let's find the average between those two. So finding the average, or the halfway between those two particular points, we can see that the limit as x approaches 0 of 1 plus x, all raised to the 1 over x, is approximately equal to the average of those two particular values, or 2.71825, which actually is really close to our value of e. In our second example, we can see here that we want to evaluate the sine of x over x as the limit as x approaches 0. And you can see with direct substitution, we're going to get the indeterminate form of 0 over 0. We can enter this function into our graphing utility. We're graphing the sine curve, so it would make sense to make our x values maybe between like negative pi and pi. We're going to use negative 4 and 4. And since we know that the sine of 0 is 1, between 1 and negative 1 or between 2 and negative 2 should work pretty well for us. And then we can adjust our table set to look at closer increments of this. So let's go ahead and input this into the calculator. So I've input this into the calculator, the sine of x over x. I've set my window with my scales, and we will go ahead and graph our function. Now we can trace this and see what happens, and see what our limit is as x approaches 0 from the right and the left. And as we thought, it's going to be undefined when it reaches 0, but it should be getting very, very close to 1. We could go to our table and set that up and evaluate that. So I have done that. My table start is at 0. I'm going to just count by 1/10, and we'll take a look at our table. And here you go. We can now then take the average of these two values between negative 1/10 and 1/10, and you see that's really, really, really close to 1 plus 1 over 2, or really super close to 1. So we are going to call that the limit is approaching 1. And we'll get some more practice with this when I see you in class.